really need much introduction because he's been a resident now for several years. Bruce Levell is actually still, I believe, technically a visiting professor in earth sciences at the university here, but I'm delighted to say that his visit has not been transient, and he's been here for several years now, and we hope to keep him longer. And as Professor of Earth Sciences, of course, there's none better to give us this virtual tour, a virtual field trip of the geology of Iffley. So now I shall disappear and sit back and enjoy with you his talk. Thank you very much, Bruce.
Thanks, Elizabeth, and thanks, David, for setting this up. I seem to have managed to draw red lines on the first slide, so it's not a good start, but we'll survive. It was the original intention to give this talk sometime in the spring and to take you all on a walk around the village and see what I'm going to be talking about and then finish up at the pub somewhere. Maybe we can still do that later in the year, I hope so. Certainly more than willing to take people around and help you find the things I'm talking about. And yeah, that would just be fun. So I thought I'd start off with this slide. It's winter at the moment, so we're doing this trip virtually. And the original title I was given was Geology of Iffley, a virtual field trip. But thinking about it and putting it in context with where we are now and looking at the Geology of Iffley, I thought the best thing to call it was actually the Geology of Iffley staring at the walls. Because that's what mostly we're going to be doing. We're going to be looking at the rocks which are in the walls, which are such a feature of Iffley. So we're going to start off with a geological map. This is going to be a bit frightening because it's complicated, but don't panic just quite yet. I'll take you through it and we'll build this map up. We'll come back to it during the course of the talk and I'll build it up gradually. So for orientation, I've coloured in the ring road in blue. That's the southern part, the eastern part and the western part of the ring road. The Thames Valley and the Cherwell Valley you can see in yellow with the alluvium in the yellow colours. The Iffley Road up to the plain, I've coloured in this and other diagrams in red. And Churchway is coloured in black. So hopefully you can now locate yourself. The colours on the map represent the geological units, and there's a scale, a key on the right-hand side. The oldest unit in our area is the Oxford clay, and the youngest unit is the alluvium of the river valleys. And the first point I want to make is that the topography that you know is of course due to the geology. And I want to explain some of the relationships between the topography and the geology. As we go through the talk, because we're going to be jumping around in geological time, if you look at the upper left-hand side of the pictures, then you'll see a little number which will be the age that we're talking about in years. I'll try and point that out as it comes along. So first of all, I'm going to deal with the youngest deposits, and I'm going to be talking about the Pleistocene terrace gravels, which you've probably noticed. And they're the main reason why the city of Oxford is where it is. So the terrace gravels are made of pebbly material deposited during a time when the Thames was flowing more rapidly and was bringing pebbly material from the north towards the south, and it dumped some of that in its valley, and where those materials were not subsequently eroded, they remain, and they define the shape of the city as we know it. So the hill that you come up from Folly Bridge, the hill of High Street, and then the long, rich areas of Summertown, which are on, of course, the well-drained soils. Now, if you come to South Oxford, a similar story applies to the character difference between the Iffley Road and the Cowley Road, because the Iffley Road, which was where the landed gentry built their villas as Oxford extended in Victoria times, is on well-drained soils, and the Cowley Road is on the Oxford clay, which, surprise, surprise, is a clay and not particularly well drained. So you can see that on this map, which is a simplification. On the right, you've got the old road layout. Iffley's circled in the red. And you can see the Iffley Road and the Cowley Road are coming into the plain. And on the left, you can see the terrace gravels. These are the so-called Summertown Radley Terrace. So it's a river terrace which has the same height between Radley and Summertown, so it's probably of the same age. It gently slopes with the fall of the river from the north to the south, but essentially the same height. And that is the high part of the Iffley Road by St John's the Evangelist, for example, up to the Co-op on the Iffley Road. And the Quarry Road, by contrast, goes through the Oxford clay, so that would be a less well-drained soil and typically would be kept for agriculture maybe a little bit longer or for poorer quality housing. Iffley is in a different setting. So Iffley is on rock of a sort. It's a fairly sandy, loose rock, but this is bedrock material which is of Jurassic age, which is much, much older than the terrace gravels. But you can see as you look at that map, the geological boundaries, it doesn't matter what they are at this stage, but if you look at the roads in Florence Park, for instance, they beautifully follow, actually they follow the topography, and the topography is made by the geology, therefore the geology is controlling the road pattern. And if you look at Rose Hill, you look at the area around the oval, then you'll see that the road pattern beautifully follows the boundary between the Ampthill clay and the Beckley sand underneath it. So the Ampthill clay is in the greenish colours at the centre of Rose Hill, and the Beckley sand is, we'll hear a lot about later on, is the orangey material underneath Iffley itself. So you can see immediately that the geology is controlling real estate values and therefore when things get developed. So if we zoom in on our village, we'll come back to this map a few times. This is the local geology. We've got Church Way, which follows just above the boundary between the Beckley sand and the Oxford clay underneath. Don't worry about the names for the time being. The Beckley sand is a sand, the Oxford clay is a clay. What that means is that water flowing through the Beckley sand doesn't flow through the Oxford clay, but emerges as springs along Church Way. So if you built your house along Church Way, you would be able to get a water supply which was filtered by the sand, and you didn't have to go with a bucket and get it out of the river after the people at Oxford had used it upstream of you for whatever purposes they wanted to use it. Shown on that map are a series of numbered points, and those are the stops on the virtual tour of Iffley. And I do have an A5 little brochure that I made for the walk that we are not going to have. And if you want to pick it up from us at Seven Tree Lane, then you're welcome to drop by and you can visit those spots for yourself. But I'll discuss each of those as we go through the talk. So I'd now like to go back in geological time from the present. So we're going backwards. So if you look at the top left, this is 300 to 500 CE, Common Era, or AD as it used to be called. And we're talking about the Romans. And I wanted to mention this because of the kiln sites that are found in Rose Hill. So there are 4 kiln sites where pottery has been found. And this beautiful mortar was on display in the Pompeii cooking exhibition. It was right in the corner at the back of the gift shop, behind the gift shop in the Pompeii exhibition. So I snuck a photograph of it with my phone. This is not made of local material. The clay probably comes from Shotley, as I understand it. It was easier to transport clay to the kiln than to transport made pots from a kiln site built on the good clay. So they built the kilns essentially market driven rather than supply driven, because I guess the breakages were less. So this is not local Iffley clay that was used here. It's not the Ampthill clay from Rose Hill. But nonetheless, clay was used in our area in the Roman times. We go back a little bit further, 4000 to 2500 BCE, so BC, and we're looking at the upper surface of the terrace gravels. And I have understood from experience that it's not allowed to give a talk to the Iffley History Society without having a picture of a Victorian gent with a large moustache, so let's get that out of the way. This is Alexander Montgomery Bell, who was an amateur collector who went around in Iffley trying to look for artifacts, and he describes finding behind Fairacre House, which was in the region of Fairacre Lane on the other side of Donington Bridge Road, gravel overlaid by humus, where he found many flints on the surface, and he found essentially shallow linear shaped shafts sunk down into the gravel to extract the flint from the gravel, and he found cores and worked flint material. And interestingly, probably his mate in Fairacre House, Charles Daubeny, was an early geologist as well. He's got fossils that he named. So that's some of the youngest geological materials, the Neolithic gravels. They were worked. There was a pit, which is at this site on the bottom right. You see Arnold Road, which comes onto Donington Bridge Road. That's about the centre of Cornishs Pit, which was worked until the early part of the last century, and was visited. So it still existed in the 1920s in some form, maybe part of the pit, and were visited by Sandford. And he described 14 foot of gravel. This is in the Summertown Radley terrace. And he described a sequence of fossils. Actually, it's a fantastic sequence that they got. They found mammoth at the bottom, mammoth teeth. They found woolly rhinoceros remains, then rhinoceros, and then red deer, and at the top horse. And as you will have already noticed, that's a climatic amelioration sequence going from animals which like the cold to animals which didn't particularly like the cold. So you've got essentially a deglaciation sequence there preserved in the fossil sequence of that gravel, which is quite remarkable because gravels tend to be fairly chaotically deposited. And they also found in the courses of working this pit 185 artifacts which are dated as Middle Acheulean, if I pronounce that correctly. That's Paleolithic, and in geological terms is marine oxygen isotope stage 6, which gives us the age of around about 150,000 years BC for these gravel deposits. That's all now backfilled. It's not indicated as backfilled on the geological map, which is probably an error. What is indicated as backfilled is the red slashed material, which is the aureal field. Okay, so let's talk a little bit about these terrace deposits. So if we look at the Thames from Thames Head down to its junction, or down to Iffley itself, then obviously the river has a gradient, and that gradient is shown in the thick black line, the modern gradient. The diagram is wrapped around, so it goes down to the Goring Gap. So Iffley appears on it twice. So you have to put the bottom pit on the right-hand side of this diagram. That gradient is a graded profile of the river. Now, at times when, in the past, the river has been at higher levels, so it's cut down into its present valley. So we've got preserved terraces which are higher on the valley sides, and those are the dashed remnants. They're not present everywhere, but you can find them. And they typically have a slope which approximates that to the modern river. So the fall, the gradient of the river was about the same as the modern one, but there are higher elevations as the river is progressively eroded down. And the higher the elevation, essentially the older the terrace will be. So as I said, at Iffley, we're dealing with the Summertown Radley terrace, and then above that we have the Longhanborough terrace and older terraces as we go up. And there's a whole flight of these terraces, which were studied by geomorphologists for a very long time. And that whole flight looks like this. So this is then the full diagram with everything put on it. This is a cross-section which runs from the left-hand side. It's elevation going up. It's 0 to 200 meters about. And then from left to right is horizontal distance, and it extends from Moreton in the Marsh to Clacton, which is probably the only time you'll ever hear those two towns in the same sentence. So there we've done that, good. So we've got a series of terraces, and the oldest ones, as you now know, are the highest ones, and the river has been cutting down to the lower ones, to where we are now. And some of these have been dated by various means, by radiocarbon dates or by fossil dates or artifact dates. And not everything is dated, but the dates that we have we have the dates from the Cornishs Pit, the Middle Acheulean, the Paleolithic, that's put on there at Iffley, 150,000 years, Ka. And then the Wolvercote Terrace, as you go up towards the Wolvercote roundabout, you go up another nice bump just outside the village of Wolvercote. All these old villages are generally built on the highs in the floodplain, of course. So then that's 300, and then by the time you're at Longhambra, you're up towards 600,000 years ago. Now, the particularly intriguing aspect of this diagram when it comes to these terraces is that there are terraces at 200 meters with gravel pebbles on them, the so-called Northern Plateau Drift near Morton-in-the-Marsh. Now, this raises a number of questions. Firstly, the Thames hasn't cut down 200 meters in the last million years or so. That's way too fast. So this indicates that the land was actually higher at that time. It also raises a problem because how the hell did those pebbles get over the Cotswold Scarp? Because the Cotswold Scarp is made of limestone and it doesn't supply quartzite pebbles. And these pebbles are actually matchable. Some of them even contain fossils. They're quartzites, they're Ordovician quartzites, and they're derived from Brittany. Now, they came to Britain about 240 million years ago in the Triassic, when rivers from Brittany crossed the Channel and deposited pebbles around Birmingham, as you would. Now, those pebbles have suddenly got from Birmingham over the Cotswold Scarp into our area. And how did that happen? So here's an explanation by a mate of mine from the department. This is a topographic image of the modern topography. So Iffley is the red dot, just south of Oxford on the Thames. You can see the Thames curling off on the upper Thames Valley, the UTV. And then we've got a series of linear hills. We've got the Cotswold Hills in the north, where this Northern Plateau Drift is found. And then we go down into the broader Severn Valley, or the Vale of Evesham. And then you can see the hills of the Malverns and the Welsh borders on the left-hand side. So you've got the Vale of Evesham, the Cotswold Hills, the Upper Thames Valley. Then you've got the Corallian Escarpment, which is the route taken by, is it the A419, the Swindon Road from Botley Roundabout. Then we've got the Chiltern Hills, which are the chalk hills in the south, with a valley in between with Didcot and Whitnam Clumps and so on in it, okay? So you can see that the Thames actually mostly flows along strike. So it flows along the soft rocks around Reading, and then it breaks through the Chilterns at the Goring Gap, and then it breaks into this other valley, which is also northeast, southwest oriented, because that's easy to erode. And you can see how it broke through the Goring Gap, I think, because you can see the tributaries of the Thames which almost break through, but don't quite. And if those retreat headward and erode backwards, they'll eventually reach the scarp of the face, and then you've got a through connection through the hills. So it's essentially headward erosion of the river channels, which breaches these hills and allows them to come through. Now, the theory is that you need to allow, you basically have to fill up the Vale of Evesham, and you have to erode it subsequently in order to be able to sweep these pebbles from the Birmingham area onto the top of the Cotswold Hills. So there has to have been solid material, either ice or sediment, in the Vale of Evesham, such that you could transport pebbles onto the top of the Cotswolds, and then they could reach the Thames system. And there is evidence for that in the fact that there's a general dip to the whole area. So we've got here the Cotswold Scarp on the left. This is a cross section from Morton-in-the-Marsh down to the Goring Gap. So we've got uplifted and tilted rocks. And this tilt is somewhat greater in our region than it is elsewhere in the UK. And that's attributed by Tony Watts, who did this work, to erosion of the Vale of Evesham by glacial material, which removed a vast amount of essentially muddy material, the Lias group and etc., washed it out into the Severn estuary. Removal of that load allowed the crust to rebound exactly as it does at the present day in Scandinavia, because it's still responding to the uplift, is still responding to the loss of weight of the ice caps over Scandinavia. So you end up with these raised beach terraces. So in our area, sediments have gone. You end up with an uplift, which is flexural because it's a response of the Earth's mantle about 150 kilometers down. So it's a large scale feature. And that uplifted this material and brought these pebbles to a higher elevation where they were subsequently eroded down the stream to form these terrace gravels. So you've got, quite a dramatic story here. These pebbles coming from Brittany, coming to Birmingham in 240 million years ago, and then making their way across the Vale of Evesham before it was there. And then the Vale of Evesham allows the uplift of this area to bring those to a higher elevation of where they are currently at 198 meters in that northern plateau drift. Okay, I want to go back one. If I just go back to this topographic image, one thing I'd like to point out before we go on is that the Corallian escarpment peters out as we go towards Cambridge. So as you go towards, as you drive along the road through Farringdon to Swindon, you're always on an uplift, and you look south across the Vale of White Horse, which is the valley to the south, over to the Chalk Scarp, and you look the other way towards the back of the Cotswold Ridge. But as you go towards Milton Keynes, it's just a big wide open valley. And the reason is that the resistant rocks of the Corallian, and I'll explain what that is shortly, disappear at around Brill. So Brill and Muswell Hill are the last outliers of the Corallian, which are resistant to erosion in the direction of Cambridge. So you end up with a very broad open valley as you go towards a Milton Keynes, Cambridge area. And that valley is a valley because it joins up the clays which are underneath the Corallian. So in the upper Thames Valley, you have the Oxford clay, with the clays which are on top of the Corallian. So between the Corallian and the chalk, you have the Ampthill clay, as at Rose Hill, and the Kimmeridge clay. So you end up with three clays on top of each other in the northeastern side of this picture, where where those three clays are separated by limestones towards the southwest. And you'll see that in the landscape, or you used to be able to, because of the chimneys, because that's a good area for making bricks. So a lot of the London bricks were made from Oxford clay and came from that area up towards Buckingham, because you've got all three clays on top of each other up there. So you can make nice big pits, and it makes economic sense. And Brill and Muswell Hills are the last vestiges of this Corallian escarpment, which we'll shortly find out has something to do with corals. Okay, so if we come back to the geological map, we now understand that the roads follow the topography follows the geology, so geology controls our life, certainly mine. And then we know about the terrace gravels, which are the beige coloured, biscuit coloured material where the city is built and where the better housing is. And then the key on the right-hand side shows a series of colours which you can best understand by looking at the map in between Iffley and Shotover. So Shotover is the highest hill in the nearest area, and surprise, surprise, it's got the youngest rocks on top of it, because younger is deposited on top of older. So on top of Shotover, you have the lower green sand, which is a mineral-rich, iron-rich sand, which was used to make Shotover ochre, for example, the yellow pigment. And then underneath that, you have a series of purpley colours, which are familiar names like Portland and Purbeck. These are the Jurassic rocks from the Jurassic coast, but they're very thinly developed in our area. Then in the brick-coloured orange, you have the Kimmeridge clay, which is one of these clays I've just mentioned. And then in the purpley colour, the Ampthill clay, which is in our area the allotments and Rose Hill. It's just on top. It's a thin skim on top of us. And then Iffley village is made of two rocks, mostly the Beckley sand, which is the yellowish colour, which you see, for instance, under Churchway. Unfortunately, life being what it is, Iffley's on the edge of two geological maps, and they use different colour schemes, slightly. But the Beckley sand is essentially the rocks underneath Church Way, and then underneath that we have the Oxford clay, which is in a mucky green colour. Now the Beckley sand is transitional or interfingers with a unit called the Headington limestone, which was the limestone that was quarried in Headington. These two rocks are the same age. The Beckley sand is, you've got it, it's a sand. The Headington limestone is a limestone. The limestone is made of corals and shells. The sand is made of quartz. And this reflects a landscape which consisted of coral reefs and nice white carbonate beaches, shelly-rich carbonate beaches, interspersed with tidal channels which were carrying sand backwards and forwards in stronger currents. So that's what you have to imagine. And the rocks underneath Iffley were made by that combination. Okay, so now we zoom back in, and I'm going to show you the geology of Iffley by virtue of some boreholes that were drilled in the village, whose records have been able to retrieve. So here we have again the map. The green is the older rock, the Oxford clay at the bottom. The yellow is the Beckley sand, named for Beckley near Otmore. The brown is the Ampthill clay, which is named from Ampthill in Bedfordshire, and then the white is the younger river deposits. And there are three boreholes I want to discuss and show you in the next diagram. One is drilled in the recreation field down near Meadow Lane. The one to the south is drilled outside 8 Meadow Lane, which is the house which has just got its gate built on it after a while, on the Mill Lane, sorry. And then 11 is drilled. It was drilled on the corner in Mill Lane outside the rectory. Okay, these are simplified versions of the boreholes put on a cross section. So the blue line where it says surface is the surface, and that goes from the recreation field, and it goes up 23 meters according to my GPS when I'm running. It feels like a lot more, to Mill Lane, and those are the two boreholes in Mill Lane, one in 8 Mill Lane and the other one by the rectory garden. And these are the borehole records. So they drilled down only short distances. And you see the Beckley sand. And the Beckley sand is indicated there as in yellow with some blue lines within it. Those were limestone layers that they found. That means the shelly material within the Beckley sand. And the weird shaped lenticular object towards the top, which is coloured in brown, is a nodule, which we call a dogger geologically. This is a cemented piece of sandstone, and we'll talk a bit more about those shortly as well. They then went into a unit which needn't bother us. It's called the West Walton member, but it's basically part of the Oxford clay, which is coloured in brown. It's a transitional unit, slightly sandy. And then they went into the full-blooded Oxford clay. And these two boreholes correlate, not surprisingly, because they're almost next to each other. And you can see that the layer of Oxford clay reaches the surface at the bottom of the hill, and then the layer of Beckley sand reaches the surface around about Church Way. And they recorded the water in these boreholes, and the water table is indicated by the blue. So the water you can see is held up by the impermeable layers underneath and sits in the Beckley sand. And higher up on the hill, of course, you've got the houses which have wells, which drill down to that water, which is perched on top of the Oxford clay. The recreation ground borehole was a bit less spectacular. They found a big thick sequence of made ground, which just means rubble and stuff that's been disturbed. That's probably from Church's Pit. Then they went into in situ river gravels, and then they were straight into the Oxford clay. So you can see it's quite a logical sequence. What's not on this diagram is if you'd have gone further up the hill and you walked past the church up to the allotment, then you would have found the Ampthill clay on top of the Beckley sand. Okay, now I'm going to tell you the geological history, and now I'm going to go to the older rocks and go back to younger rocks, because it's good to start with the beginning and end with the end. So I need to go first to the Oxford clay, and then I'll walk you through to the Amtil clay. So the Oxford clay is known in our area. There have been spectacular fossils found. So next time you go past the Iffley Road Sports Ground, don't necessarily think of Roger Bannister. Think of the crocodile that was found there, which was 160 million years old, dug up when they excavated the running track. And then when you go to Tesco's in Cowley, it's built on the site of the Cowley Road brick pit, which was where they got the clay to make the bricks for a lot of East Oxford. And there was an Iffley brick pit. There are records of an Iffley brick pit, which must have been somewhere around Florence Park. I haven't been able to work out exactly where it was. It was open in 1837. When it closed, I don't know. The Oxford clay is very good for making bricks because it's organic rich. It has lots of carbon material within the clay. This is detrital woody material which was swept into the sea, which at that time was tropical. And that means that when you stick it in a kiln, the bricks self-fire. They get combustive energy from the mass inside the brick as well as from the kiln itself. So they get a very even firing, which is why the Oxford clay was favoured of all of these clays for making bricks. What would it look like, these brick pits? Well, there's an excavation at South Parks Road with Tony Watts, who did the work on the Vale of Evesham and the Plateau Drift. And there you can see the excavation and the fresh blue Oxford clay just been scraped away by a digger. Okay, this is then what you see when you go to look at the Cowley Road brick pit. That's Union Street. The car park is actually the brick pit. Okay, so if we take a cross section again through Iffley, but then up towards Brill, and Brill you now know is significant because it was the end, I told you, it was the end of the Corallian sequence where these harder rocks disappeared and were replaced by clays. So Iffley is in the red box. Churchway, if you were to indicate its geological position, this is a cross section. So it's got height 0 to 70 meters against distance 5 kilometer scale. But if you were to put Churchway in its geological position, it would be where it is. And Tree Lane essentially goes through the Beckley sand and up to the top of the hill and ends up on the Amtil clay towards the co-op. Then this is the relationship between these Corallian units. So the Corallian is a name given to the rocks with corals in. It's an old-fashioned term, but it's still used. The Beckley sand is the sandy unit. The Littlemore member, LIT, is named for Littlemore, and is a mixed muddy limestone unit. It's from the more offshore parts of our tropical shell-rich beaches and our sandy tidal channels. And then WL is the Wheatley limestone, or the Headington limestone, which is a unit of the same thing. These are the bona fide reefs and the off-reef material where you would like to snorkel. So this is nice white carbonate, shelly sand, clean, bleached, being moved around by waves and making a nice building stone. And then as you go off towards Brill, these units disappear, and the Amtil clay is the time equivalent actually of some of these units. So at that time you would have gone from the beach to the offshore mud if you'd have swum far enough out to sea. Yeah, okay, so that is that. Okay, so if we then look at what these reefs would have looked like in the Corallian and what these tidal channels would have looked like, there was a guy called Arkell who was the son of the brewing family Arkell, and geology was essentially his hobby, but he became a professor at New College of Geology, and he amused himself by going out with an auger into the fields and trying to work out where you had tidal channels filled with muds or sands and where you had these limestones which were coralline. And this is a map which he made. He published several of these actually during the war, but this is one that's just pre-war. And it shows the area around Boars Hill. Now, he could only find the limestone where it's close to surface because the poor guy just had an auger, so he could only go down a few feet, which is why the centre of the map around Boars Hill is blank, because to drill down to the Corallian there, you'd have to go more than 50 metres or so. So he could only work around the edge, but nonetheless, the dark blue are the areas where he found limestones, which were reefal limestone, and the light blue was where he found these channels, which were going through the reefs. So this gives you an image, essentially, a picture, a satellite image of 160 odd million years ago, where you would have had nice limestone beaches and reefs, and where you would have had tidal channels with currents going in and out, and a lot more mud. And there is a plausible theory that where the Thames broke through this ridge of Corallian rocks, which are harder to erode, at Iffley, was because there was 160 million years ago a bigger tidal channel where the Thames actually has now broken through. So the river will in general find the weakest rocks and go through. There's a certain amount of inertia involved with water, so that doesn't always happen with a great degree of fidelity. But nonetheless, it's a plausible theory that the stretch between Iffley and Sandford, which is one of the biggest falls on the river over a short distance, is actually attributable to the fact that in the Jurassic there was a tidal channel at that position. You can do a similar exercise towards, and Arkell did, on the other side of Oxford, and this is his map of where there were limestones within this Corallian interval. And you can see Forest Hill, which is a hill, Wheatley, and the area around Beckley. These patches of limestones are giving you an indication of the size and the shape of the reefs that were involved. And one of the biggest is the one around Headington, which was obviously quarried for building stone. The best quality stone actually came from Wheatley. That's because it was on the edge of the reef where the sand, the shelly material was actually sorted by the waves very nicely. So it's an even grained rock, and we'll see that shortly in the walls. So this is what it would have looked like. I've rotated the satellite image from the Persian Gulf here, or the Arabian Gulf if you prefer. And I've indicated roughly the position of Iffley, Headington with its quarries, Beckley with its sands, Wheatley with its wave-washed limestones, and Brill being the last place that the nice shelly beaches occurred. So Iffley, some kind of tidal channel because we're mostly sand. Headington, in between the channels, carbonate tidal flats and coral reefs. Wheatley, outboard of the coral reefs. Beckley's in a different tidal channel to Iffley, but another one. And then Brill, the last island offshore. And the Corallian's called Corallian because of the corals. So on your right hand side, you have branched corals and colonial corals and solitary corals, which you can all find around Oxford. Some great examples in the walls of the church on Corn Market, for example. So if you go to Brill and look back towards us, then you can see here indicated in yellow, the two yellow arrows, the Corallian Ridge, which goes from Beckley, goes down into Otmore there, which is on the Oxford clay, that's why it's boggy. And then it goes all the way to near Waterperry on the left-hand side. That ridge is this ridge of limestone, which used to be coral reefs with tidal channels. Iffley is where it's indicated. The chalk scarp is in the far background. And if you turn around and face the other way from the same position, then you don't see any Corallian scarp at all because the reef ended. And that's this wide, broad valley up towards the northeast that we saw on the topographic map. Okay, so now let's talk about Iffley and go around the village. So the first thing is the quarry. So there is this lane called Stone Quarry Lane, which is where presumably the quarry is to be found. I'm confused by this story. I found a document by Reverend Hills, 1979, where he was actually protesting against the choice of names that have been selected for the new housing development and recommending a series of names that were more locally appropriate. And he said that, you know, from time immemorial, there's been, it's known as a quarry, and he rediscovered this quarry, and it was being used as a rubbish tip. So that's one documentary source. And then the other one is that Arkell, in the Geology of Oxford, went through the Merton College accounts, as you do, and found a bill, or a series of bills, and I think there were two, which were in payment for stone which had been derived from Iffley, and these are from 1290 or so. And he states that by the end of the 14th century, the Iffley quarry was worked out. So I struggle to believe that you know, the quarry was a depression which was recognizable as a quarry 500 or 600 years later. So maybe that's the case. Maybe there was a folk memory, but possibly this is the site of the quarry. What I can offer elucidation of is the fact that it wouldn't have lasted very long, because, as you now understand, we're on the edge of a tidal channel and we don't have much of the reef. And the stone they would have been after is basically the limestone. It's easier to work, and it's a better building stone. A lot of the sand is incredibly loose. It's not even really a rock. It's just sandy. So it's in fact, when we dug out the basement in this building, it was 95% sand and about 5% rock, and that's the Beckley sand. So there was a quarry in Iffley. There's a documentary record of it. It may have been in this location. Who am I to say? And but it was worked out probably very quickly, because it had a low resource. Sorry, this diagram attempts to explain that. You can see a series of boreholes here, which document the succession, and Iffley is again in the red box. You see, it's on the edge of the Wheatley limestone occurrence, in between these two settings. Now, completing the story of going up through the sequence, the youngest rocks we have in our area are the clays of the allotment, and these are the Amptil clay, which is younger and coeval with the Corallian. And these fossils were given to me very kindly by Marianne Casey, who said she had lots of these. And these are sea urchins. These are Echinoderms, echinoids, and you can see the pentameral fivefold symmetry. The petal-shaped bodies are called ambulacra. These are the areas where the tube feet of the echinoid would have projected out. And then on the underside of these fossils, you can find the mouth, and the notch is the anus. So this is Nucleolites cunicularis. They could be easily identified, and these are apparently plentiful on the allotment. So thanks to Marianne for those. If we go now around the walls of Iffley, back to the geological map one more time. I'm going to show you, first of all, the ammonites. So there was a little publication on these, which Greg Birdseye put out in his miscellany recently. So we're going to see some of these. There are a number of ammonites on the walls in Iffley. Here are some of them. We've identified them as Perisphinktes pickeringhensis. Perisphinktes, the classical scholars of you will know what it means. There's an interesting story there that there were two professors who unsurprisingly did not get on with each other, as is their wont. And one of them met the other in the corridor one day and said, Professor Bowen, yes, nice to see you. I've just named a fossil in your honor. And Bowen said, oh, it's very unexpected, very kind of you. What did you call it? And he said, I called it Perisphinktes boweni, or in the vernacular, around the arsehole of Bowen. So that's Perisphinktes. It's got the name because it's an even coiled fossil, which looks like a sphincter. And these are some examples. The one at the left, A, is from Tudor Cottage, courtesy of Patrick Lawrence. The one B in the middle is from the turning bay in the wall at the top of Tree Lane. It's about 50 centimetres above the tarmac, absolutely slap bang in the middle of the wall, beautifully symmetrically placed, and sometimes it's covered by weeds, but I think Peggy or someone goes out there and cleans them off, so it's normally visible. And then the one on the right, the black and white image, is the one that we found when we dug out the footings in our basement. You can see that the fossil has a series of strong ribs, and these ribs bifurcate over what we call the shoulder, the back of the ammonite, and they're swept slightly forward. You can count these ribs on each whorl of the ammonite, and that helps identify it. Now, the interesting thing about the preservation of these ammonites is that none of the original fossil material is present. So there's nothing of the shell of the ammonite there, but nonetheless you can see the ammonite. Now, in the jargon, these are casts of external molds. So what's happened here is that an ammonite has fallen down on the bottom of the sea, and it's impressed its shape into the underlying material as it gets squashed by overlying material. And it also impresses its shape into the overlying material, so that as sediment is deposited on top, it leaves an imprint both above and below. Now that is a mold of the external part of the ammonite. The shell then dissolves. What's happened in these porous rocks is that a lot of the carbonate material, calcium carbonate, has dissolved, particularly the aragonitic components, of which ammonite shells are made. And so there's no shell material left, but there is a faithful imprint on both sides in this firming up sediment, not yet rock. Now, if by chance some different sediment should filter into the cavity which is left after the dissolution of the fossil, then you can create a cast of the external mold. Are you with me? So you actually fill the hole, you create a cast of the external mold. And that cast is actually, in this case, made of sand, which filtered in to the hollow that was left by the ammonite. Now, that's a fairly extraordinary set of circumstances, which is perhaps the reason why we don't find so many of these preserved. It's a lot easier to preserve the original fossil. And you can see on the black and white diagram on the right, you can actually see that part of the preservation is actually the external mold imprinted onto the underlying material, the inner whorls of the ammonite. Now, in the case of that one, in case of the 1C in Tree Lane, the story is even more complicated, because this cast of the ammonite got re-eroded onto the Jurassic seafloor as a pebble, and was then colonized by oysters, because it was one of the few hard objects which oysters could then colonize. So what you see on this are attachment scars. You can't see it on this picture, but there are attachment scars where oysters have colonized this sand replica of an ammonite which has been dissolved. And there are also serpulid worms growing on it as well. So, amazing story of preservation. All of the Iffley ammonites that I've seen to date are casts of external molds, with the exception of the Turning Bay ammonite, which is an external mold. So there you're seeing the impression of the ammonite into the sediment, not the three-dimensional replica of the ammonite itself. Okay, here are some more. This one is not strategically placed in the center of a turning bay, but is beautifully strategically placed in the center of a row of 3 rubbish bins outside the rectory. And Andrew, quite generously, he's a generous spirited guy. He leaves the gate open so you can revel in the glory of this one. This is the biggest ammonite we found in Iffley, and the large ammonites are the female of the species, which is often the case. So this is a large female ammonite, also a cast. And then here, Susie Seville, she's got 2 beautiful ammonites. There's one on the back of her cottage, church cottage, and that's beautifully placed in the center of the building. And then inspired by that one, presumably when they built the extension on that cottage on the, what would it be, the southern side. Someone put another ammonite on the extension, not quite in the middle because the window's there, but up near the eaves. And you can see that in the top right of this picture. So those are the two beautiful ammonites that you can visit. And then, sorry. Yeah, okay. Okay. And then I got out of order here, sorry. Here's another set of ammonites. These are at 111 Churchway. These are courtesy of Ron Harray. And in his garden, you can see Ron there. Nice to see him again. There are actually 4 ammonites, and these are interesting because they're 2 different sizes. You've got the big ones, which are the females, which are indicated in red, the so-called macroconch, and then the male, which is indicated in blue. These are microconch. Now you can differentiate the male from juveniles because of this number of ribs per whorl story. These ammonites actually change their ornamentation through their life, and so you can make a sort of formula out of how many ribs they had on each of their whorls, and that allows us to differentiate between the microconch, which is the male, and the macroconch, which is the female. The males also had different organs which you can find preserved, and we know that the female is a female because we found ammonites with egg cases internally preserved. So if I go back now, okay, I'll go back. Oh, I want to go, sorry, I want to try and go back to, yeah, okay, can't do it. So if we then look at other fossils which we can find aside from the ammonites, this is a stone which perhaps many of you will know. This is one of the so-called doggers in the Beckley sand. This is basically a sandstone which has been cemented by calcium carbonate, probably derived from the fossils that got dissolved. And it's made it into a hard stone. This would have been useful for building, but and is in reasonably close to where the quarry must have been. So maybe it's got something to do with that. But you do find these doggers. Ron had some in his garden as well, actually. And there is a record of some outcrops of these rocks in the Rose Hill Cemetery, but I went there and couldn't find them. This one has got another sea urchin on the bottom. You can see in the yellow circle a round object with a hole in the middle, and then a bit of a shell on the edge of the yellow circle underneath it. That is the bottom of a sea urchin. It's the ventral view of a sea urchin. The hole in the middle is its mouth. That's where Archimedes' lantern would have been. And you can crudely see the 5-fold symmetry of the beast as well. That's quite nice in that in that stone there. I'll go there. Okay, so we can also find in the walls at Iffley some examples of sedimentary structures which tell us about the deposition. We can see oolites. These are stones made of round grains which have been rolled in these tidal channels. And those typically weather very badly. So you see them as this sort of decaying material in the walls. And you go and look at it with a hand lens and you'll see that those are made of egg-shaped grains, very small egg-shaped grains. Absolutely typical of the modern Bahamas bank, for example, tropical warm seawaters. You can see cross bedding. That is bedding which is slanting. This particular stone is actually upside down. It's as it is in the wall, but in nature it would have been the other way up. And this is formed from ripples migrating, in this case from right to left. That's the depositional slope of a sort of mini sand dune underwater. You can find burrows, as shown in the slide on the right. That's actually from outside our kitchen. And you can see there a worm burrow, which has been infilled with more shelly, sandy material outlined in yellow. And these are all over the place in the walls of Iffley. You can find different sorts of rocks. We've got on the lower right hand side a spectacular shelly limestone. This would be similar to the Wheatley limestone. I don't know if it actually came from Wheatley, but you can see small fragments about 2 millimeters of shelly material, all broken up and quite well sorted, all more or less the same size. Typically these are cross-bedded as well, and these are often used as freestones for the windows and the doors. They're actually not very good freestones, and they're often sort of chipped or not quite holding their square shape because they're not that well cemented. They're very porous, but they were better than the rubble which you normally got out of the middle of the reefs. So the middle of the reef, this is organic material. This is just rolled around debris, and leads to the walls which you see in the lower left, so-called coursed rubble, where it's not all the same size, so you can't make nice courses out of it. And that's a hodgepodge of material which typically would have come from the cheaper material that would have come from the Headington quarry. You can see the freestones being used in this very nice window from near the church, a house near the church, so for the facing stones of the windows and the coin stones and so on. And you can also see in this diagram, if you look closely, that the mortar is actually stronger than the rock. And typically that's what you see, that the mortar is actually between the stones, is actually doing a better job of surviving the atmospheric conditions than the actual rock. These are not excellent building stones. There's also a granite. This is near the junction with Tree Lane and Woodhouse Way. That's got nothing to do with Iffley, but it sticks out like a sore thumb as being a foreign rock. And you can find quite a lot of shells. So here we've got bivalves. These are things like cockles and mussels. Almost all of these in the walls of Iffley are members of the family oyster. And that is for the reason that oyster shells, quite unusually for bivalves, are made of calcite rather than aragonite. So these are the ones that have not been dissolved and have been preserved. And you can see these clam-like shells, chlamys and so on, and nanogyra and others in many of the walls. One of the best spots for finding these is just next to Azores Court. There's a low piece of wall on the right-hand side of Azores Court, which is absolutely stuffed with fossils. And it looks as if they got a nice wagon load from one part of the quarry, because that section of the wall is particularly rich. You can also, and here's an example from there. This is a pinner shell. This is a shell which is a V-shaped thing that lived upright in the mud, which is found there. And then the Beckley sand itself is best exposed in the lane which goes down from the top of Tree Lane back down towards Iffley Road. On the left-hand side, this is a wall which in the summer is absolutely full of solitary bees. And they're quite liking living in the Beckley sand. And when you walk past it, you'll notice that it shines in the sun because the quartz grains are glittering at you. And that's quite unusual. It's also, when we can see colours with a bit more sunshine, it's more brown than the other walls of Iffley. And that's the typical colour for the Beckley sand itself. Also on the walls in Iffley, you can see masons' marks. So the masons would take pride in their work, and they would leave the stones which they had worked with a particular ornamentation. And that's, here are 3 examples from around Iffley: a guy who liked up and down, a guy who liked a checkerboard, and a guy who liked cuneiform script by the looks of it. And I don't know if they did this in order to be paid for their work. It would be a way of identifying the stuff you'd spent your time on. There are some records of stonemasons in Iffley, and I've put those there for completeness. And the roofs. Now the roofs are also an interesting story. Typical roofs in our part of the world are made with Cotswold slate, in particular Stonesfield slate. The limestones are not very good for making slating because they don't break nice and thinly like Welsh slate. And what you want is something with a large surface area and not a hell of a lot of weight. But there are Stonesfield slate roofs. There's one there on the left. I'm not sure, I haven't done a census in Iffley to find all the Stonesfield slate roofs. There's an extremely fine one in New College Lane, which is the best one I've seen. These are from Stonesfield. And in the top, you've got a natural exposure of the slatey type material, which you can see is not very slatey, but it is thin bedded. And in the bottom, you can see the walls if you walk around Stonesfield, and you can see these thinner units than normal for a Cotswold stone. Stonesfield is famous for having some of the earliest known mammals, basically known by their teeth. So the quarry was a major source for early mammal finds, which is the reason for the lithograph in the middle. Stonesfield slate has an interesting story. I'll tell it really quickly. The rock does split naturally into slabs, but they're still too thick for roofing. So what do? Well, what you do is you get a bunch of kids and women and you help them break up the slate. So the men would quarry it, and they got this thing called pendle, which was the natural stone, the thinnest they could get. And they would take it into the fields and lay it out in the winter. And when there was a frosty night when there was a weather warning for frost, they got the Met Office app, they rang the church bells, and the whole community went out in the field and sloshed all of these slates over with water. They wet the slates, and the frost would crack them and split them into thinner layers, which they could then sell for money. So a back-breaking labour. And they had to preserve the quarry sap. The stones came out of the ground wet. And so if it was dry before it got wet in the winter, they would actually have to cover them with earth in these stacks in order to keep the sap in. Because once the thing dried out, however much water you threw on it, it would never get enough water in it to split it. So they had to preserve the wetness from the quarry and then to the winter, and then wet them, and then they would split open and they would sell them. And that is commemorated in the church. They've got this wooden board with a piece of slate underneath the church tower in Stonesfield as a memorial to the work which the village labourers would have done to get their crust. Now, lastly, you'll be glad to hear, we're getting to the end. I wanted to say something about the deeper underground geology below Iffley. And what I've got here is a seismic line which has been shot along the bypass. So this was shot from the bypass where we join the A34 by Kennington up to the Wolvercote roundabout. So it goes, the gap in the middle is where they presumably weren't allowed to shoot under the bridge at Botley. I don't know exactly the reason for that. But this was acquired with in 1985 by 4 of these vibrators. This isn't the actual vibrator, but I wondered if anyone noticed this happening even. There would have been 4 of these trucks. They would have gone together. They would have parked next to each other. They lowered that base plate onto the ground, and then they vibrate themselves at a range of frequencies. And then they have geophones, such as the one on the right, which is in our garden doing the experiment for a short while this year. And they would have recorded the sound waves returning from the earth, and they would have been highly disappointed with what they got. What you can see on this seismic line is basically flat-lying geology, which is the Jurassic, and then noise underneath. So they would probably have liked to have used more of these trucks to get more signal down. However, other people were more successful, and I can show you the deep geology underneath our area, and that's on this line. So here, similar process. This is over towards Farringdon. You can see the Jurassic is fairly flat at the top, and then underneath, all hell breaks loose. The rocks are bent and folded and broken, faulted, and this is the Oxford coalfield. So unbeknownst to many people, if you go down about 400 meters, 300-400 meters below Oxford, you're into a coalfield, which they actually thought of exploiting. It's just outside the range of open casting, but during the war, when things were desperate, they actually investigated this a little bit. It's coal-rich strata, and there's about 1 kilometre of it, and that is a map here of where it is. So it's we're on the edge. There's a trough between us and Farringdon, and if you go down about 1 kilometre, you're well into coal-bearing rocks. Now, what's the relationship actually to Iffley? Not a lot. It kind of completes the story with the deep geology. We have 2 bits of Carboniferous that I could bring for your delectation. One is the millstone grit, which made the millstone, which is in the cottage on Mill Lane, which you'll see when you go down to the river. And the second is the Tournesian limestone pillars from Belgium, which are in the church. And if you were to go down probably about 1.5 kilometres below Iffley, you might even find the Tournesian limestone, but it's probably cheaper to bring it by ship from Belgium. Okay, so that brings us to the end of our gallop round the Geology of Iffley. I hope I haven't taken too much of your time. The talk is there for you if you want it, and if anyone needs the slides, I can also make those available. So this is what we'd hoped to do a tour of the village in the summer, but I'd like to finish with the hackneyed quote, "And now is the winter of our discontent made glorious summer." And I wish you all a happy summer and enjoy the walls of Iffley. Thank you.
Thank you so much, Bruce. That was truly fantastic, across the ages and down the depths and all over the place, from real crocodiles to potential coal fields to understanding that we might have had Tournesian marble under our feet if we'd gone down far enough. I'm so grateful for that fascinating talk, and also that there will be a recording, because there was so much meat in that. I'm going to have to return several times, I think, to let it settle in, to my mind anyway. So you were kind enough to say you'd be prepared to take questions. I'll just see if there are any in the chat box yet. No, I don't think so. So any participants who have a question, if you'd like to unmute yourself and ask Bruce. Oh,
hello,
yes.
Bruce. I have a question.
Yeah, go ahead, Richard.
The soil in my garden in Meadow Lane, sort of lower Iffley, I've had analysed, and it's a sandy loam. From your talk, I think we're on Beckley sand, unlike Rose Hill, which is a clay. We're on Beckley sand. The pH of my soil is agriculturally rather high, it's 7.5 to 7.9. That surprises me for a sandy loam. It suggests there's some limestone or something effect nearby. Can you comment on that?
Yeah, I think I would expect the groundwater to be pretty saturated with limestone, to be honest. And I think where you are, Richard, you'd probably be on the West Walton member, which is this transitional unit between the Oxford clay and the Beckley sand. So it is a sandy clay, a sandy limey clay. And I think that would fit with your topographic elevation better than the Beckley sand. I think the Beckley sand, you have to go a bit higher up the lane to get onto the sand itself.
I see. Yes.
But almost everything here is limey. The Oxford clay itself is quite limey as well.
Oh, that figures then. Okay, thank you.
Bruce, in the chat box, we have somebody seeking reassurance that you said there was a leaflet we could pick up
Yes.
from you. Is it available as a PDF that you could email to us, or?
Yes, I can. I've got a little leaflet which it basically doesn't. Well, it's useful to have with you when you're walking around, but it is modest. I would hasten to add. But yes, I can make a PDF available. Yeah, I will do.
That's wonderful, and I'm sure I speak for many of us here that we do hope that.
Or what I could do
soon we can do a tour with you as well as the leaflet.
Yeah, maybe what I could do is put some PDFs in the shop. Is that a sensible idea?
Yes. Yes.
Yeah. Okay.
Here's a question from Meg Bent. What are the brown stones that we find in our gardens? So Meg's in Churchway, I think, isn't she?
Yeah, those will be the doggers probably. So if it's brown and hard and knobbly, and if you chip it, the test is if you chip it, it glints at you. Well, you need some sun. maybe a head torch. But what happens is that the sands are mostly loose, but where they're around fossils which have dissolved, the carbonate minerals from the fossil go into solution and then reprecipitate and stick the sand grains together locally. So you end up with a sort of halo around a fossil, which is why if you go down to Charmouth or Lyme Regis, you find everyone smashing on oval-shaped blocks to try and find the ammonites inside. It's because the cementation of the mudstones in that case is related to the fossil that's inside. So you might find fossils inside when you smash those open. That's possible.
Hello, Bruce. Thank you very much. What an interesting talk that was. Susan here. I just wanted to say, I remember Susie Seville telling me that her cottage had originally been built facing the other way. So the ammonite in the back of it would have been nicely placed in the middle of the front wall. And it's only when they built the extension and moved the front door round to open onto Church Way, but it was originally built as I guess, a farm worker's cottage, actually facing onto the fields behind it. And I think the rectory walls, the little garden walls around the rectory, were built in the 17th century for the archdeacon, who very unusually actually resided in Italy. There's the splendidly named Archdeacon Holyday, or Holiday, but I like to think he was really Holyday. And I think the 17th century saw quite a lot of gentrification in Italy, in Iffley, and there's quite a number of buildings built at that time or upgraded. So it's interesting to see that our first named mason is actually also of that time.
Yes.
And may well have worked on them. So the so-called manor house, which had started out life as a farm, was gentrified at that time. And then there's a lot of building in the rectory and the churchyard walls. And in the church itself, the local stone is used for the body of the walls, as I understand it. And then there is Wheatley stone and also Tainton stone, which is very nice stone from near Burford, which is used to frame the walls and any features and cornices and things within the walls of Iffley Church. So anyway, yes, thank you very much.
Yeah, that's correct. So on the placement of the ammonites, I find it wonderful that that one in Susie Seville, someone's taken a lot of pride to put that ammonite, right plumb in the middle of the elevation there of that wall. And it's a shame that we don't do that anymore. I mean, it was whoever decided to do the ammonite in the turning bay at the top of Tree Lane has given me untold pleasure. Every time I turn there, the headlights catch it, and I think, oh, that's really nice. And it's a shame that that's not done anymore when people, restore walls or whatever. Just put some nice local materials in the middle. The Tainton stone on the church is beautiful. It's really, really nice. I love it. And it's interesting if you look at the history of stone, building stone in Oxford. First order. This is first order. It's a history of the cost of transport, because you start off with Headington stone that comes down the hill in a cart, and then someone gets the idea that canals are pretty good, so you build canals, and then you can get up into the Cotswolds and you can get a better quality building stone for facing, and then railways come along and may as well go to Bath now because stuff's really good and it's dirt cheap and you can make whatever you want out of it. And then they went up to Rutland as well for the Clipsham stone. So it's essentially a sort of progressive, transport costs go down and you get a better quality stone and you replace what you've done previously. But of course, vernacular buildings had to just carry on with the lesser quality stone for longer.
I'll just chip in about transport. I've heard some person argue that the Merton accounts saying stone from Iffley was brought to the college, whether or not it just meant that Iffley was being used as a sort of depot for stone brought down from the hill maybe, or somewhere else, and was just cheaper than storing it on the college ground or in centre and just ferried up later. But I'm not good enough with my medieval Latin to know whether to look at the original, whether or not that's possible.
Well, just trying to think on behalf of a labourer, I wouldn't do that because it's not on the way from anywhere with stone. So you'd have to go out of your way to leave it at Iffley. If it was quarried at Headington or Wheatley, then you wouldn't naturally go through Iffley to go to Merton. So
no, so that's good. So
yeah, so
I mean, romantically, I'd like that. Being an old Mertonian myself, I'd like to think that Iffley stone is part of my old college, as it were. So I'm relieved about that one. I see we've had a comment in the chat box that Reverend Hill's memo has several factual errors. So we should maybe take his views on the quarry not too seriously to begin with.
Just comment on that, Elizabeth. Can I say a bit more about that?
Yes, certainly.
I transcribed that memo, which I found in the Friends of Iffley Village archives when I was sorting them out about 5 years ago. And it's quite amusing and fun, but he's wrong, for example, about saying that John Stainer, the musician, organist and composer of a lot of church music, including the oratory of the Crucifixion, lived in Iffley. That, because I explored that topic with a view to possibly putting up a blue plaque, and that turned out to be completely false. And I made some further inquiries from the church people about Reverend Hill, and he did have a reputation for being a bit economical with the truth and rather over enthusiastic, might be the politest way of putting it. And that attitude is certainly consistent with the rather fanciful suggestions he makes for the names of the roads that were, including Baytree Close and Woodhouse Way, that were under discussion in the 70s when Woodhouse Way and the whole of the southeast end of Oxford were Iffley were under development. And so I think you should take his suggestions and the logic behind them with a very large pinch of salt.
yeah, my reading of it was he wrote it when he was a bit angry as well.
Well, he was the sort of person who regarded his business to write about everything, including suggestions for names of new roads, which is a little far from his normal ecclesiastical brief. But he was given to flights of fancy and economy with the truth.
I have a question about some of the field names, Elizabeth.
Yes, well, fire away.
So I've looked into the old field names of Iffley, and there are a couple of sort of possibly geological ones. One, I don't know where it was, but there was a field called something like Wheatalong, the white strip, which was also in Latin called Alba Terra, the white land. And I don't know where it was. And I wonder if you have any suggestions for where a field might have been, a small field might have been that would have looked particularly white.
Wow. Well, the short answer is no. The long answer is if you the whitest stone that there is the Wheatley limestone. It is whitish. So, and there are limestones in a little more member which are white, which would which would suggest, all things being equal, more south.
Right. Okay.
That's about as good as I can do, really. I could yeah, the south side of Rose Hill would be, that would if it has any relation to geology at all, that's the best I can do for you.
Okay, thank you.
Yeah.
There is also a sandy furlong, which is on the other side of the ring road, sort of around where Thompson Terrace is, so in what you would call Littlemore now. And I was curious about why a field there might have been more sandy than anywhere else.
I can just flip back to the map. So you can see that
Yes.
whole area of Littlemore is basically Beckley sand. So south of the blue, the ring road, that yellowish colour, you don't see my cursor now.
Yes.
You do? Okay.
Yeah, I can see it.
So this area here, this is the Beckley sand. So this whole area down here would be sandy. The area I was thinking of for your white field would be in this bit around here. Just this stratigraphically younger. So it would be up against the Amtial clay. It would be roughly where the ring road is now. That would be, if the white has anything to do with geology, which it may well not do, could just be the wheat glinting in the sun or something.
Yes. Okay, thank you.
Bruce, where's Meadow Lane on that map?
Meadow Lane is here. This is Meadow Lane. So this hashed area is Oriel Field.
I don't see your cursor.
Okay, so it's you see Church Way is black.
Yes. Yeah.
So above Church Way there is a hash.
Yes, got it.
That hashed area is Oriel Field.
Oriel Field. Oh, good. So we're on the edge of that. Good.
Yeah.
That's good to know. Thank you.
So you're on this WW, which is what I was trying to say. This is this West Walton member, which is transitional between the genuine Oxford clay, the thick clay, and the sand.
Oh, good. Yes, that makes sense. Good. Thank you.
Well,
No.
Can I
one more in the chat box.
lower the tone a little? John Wilkes from, as it were, under the shadow of Susan Walker. A general point: are these wonderful relic survivals subject to any form of legal protection, either from people who don't wish to retain them, or from people who might steal up in the middle of the night and try and remove them? It obviously doesn't apply just to Iffley, but I wonder if there is any framework for protecting these survivals, which you have so brilliantly displayed for us.
Oh, thanks, John. So I mean, the protection comes with the building. So insofar as the building is protected, then stones embedded in the building are protected. The site, so the nearest one to us is Littlemore Railway Cutting, is a geological conservation site which is protected because it has it's a rare exposure of these rocks. So there's a whole system of geological sites which are protected. I think that includes what's left of the Crossroads Quarry at Headington, for example. That's also geologically, it's a low level of protection. They're geological conservation sites. But they are listed, and people go and check. I've got a colleague in the department, Owen Bement, who helped me with this, and he goes and checks, and the Oxford Geology Trust keeps an eye on the natural exposures, or the previous artificial exposures which are now being protected. Individual fossils don't get protection, but sites where fossils can be found do get protection. it's steadily increasing. I mean, I think it's good. And also in the geological community, there's a students nowadays are almost always told not to hammer, for example. Whereas when I was a student, which is not so long ago, but you know, we were allowed to hammer, but nowadays you're typically not. So protection is being ratcheted up the whole time.
Thank you very much.
I have a couple of comments from the chat line. This is from Ruth Dixon. When we lived in Fairacres Road, there was a covenant forbidding us to make bricks. I suppose this was because of the tempting clay all around.
Yeah.
They might have set up a cottage industry or something.
Yeah, that's interesting. So that must have been from the time when there was a real threat of extension of the brickworks. And you just look at Victorian building and you think, you know, what's the size of the hole in the ground which they had to make all of these bricks? Well, it's roughly the size of the buildings, isn't it? Well, the walls of the buildings, obviously, but you know, yeah. If you go to the Isle of Portland and you can sort of see how much stone was taken to make London, it's impressive.
And Julia Brocklesby has put in the chat line, white marls from the Littlemore member are visible along the cycle track on the bypass and behind Sainsbury's.
Ah,
if you've explored that far.
Yeah, there you go. Yeah, excellent.
And that would have been under the field that would have been called Mount Pleasant.
All right, yes.
Yeah, you have to, but I guess you have to extrapolate to where it would have naturally come out to the surface in the field, because the thing is, because the dip, the inclination of the layer is so shallow, and on the Littlemore side of Rose Hill, the inclination of the topography is in the same direction as the inclination of the layer. You can have a very thin layer exposed over a very large area.
Yes. Yes, I've only seen it where there has been exposure for the sand pits in Littlemore when the railway came through. And now the development is taking place behind Sainsbury's. It's exposed, but it's very near the surface there. I managed to collect samples. I think ordinary farming activities would have exposed it in the area going down behind Sainsbury's. I think that, you know, might have ploughing, I think, would probably have scraped it up. Interesting.
That's fascinating. Yeah, may have solved a mystery this evening.
Well, I've got a few jars of it in my shed in case it all gets wrecked by the development.
Well, as we can see from all the interjections and comments and questions, it's been really fascinating talk. Thank you so much. We've all learnt so much, and we're going to continue learning and looking and finding more and hanging out the hope that it won't be long before you'll be leading a little human crocodile of us around various parts of the village and ending up at least one hostelry, I should hope. But thank you very much. And I've got a prompt from my former publications officer to remind everybody that the miscellany in which your article on our ammonites is published is still available from the community shop. For those of you who haven't received or a copy, you can purchase one from there. And otherwise, I think it's just lots and lots of thank yous in the chat line. So it's all thanks on Zoom is always terrible, but on behalf of us all, thank you very much.
Oh, you're welcome. Yeah. Thank you. Thank you, Elizabeth.
Good night, everyone.
Yeah. Good night.